So get this. In late 2025, a researcher named Giorgio Lenci drops a bunch of scientific papers that on the surface look like they have nothing to do with each other. In this explainer, we're going to dig in and find the wild connection that ties them all together.
First up, there's a paper on cosmology. And we're not talking about a small update here. No, this thing puts forward a completely new theory for the entire universe based on information.
Then there's the second paper. This one lays out a pretty radical new technology. The goal? To actually regenerate human organs right inside the body. I mean, imagine a world that could end the need for transplants.
And the third one, well, this is the real outlier. It's a study on what drives us, what fuels human ambition, the psychology of success. It seems completely worlds away from physics and biotech, right?
So you've got the cosmos, regenerating organs, and human motivation. What in the world could possibly link these three totally different fields? Well, that's the puzzle we're about to piece together.
To find the answer, we have to start big. I mean, really big. We have to look at a whole new way of thinking about the universe itself.
This is called the nova theory, and it basically says that before the Big Bang, before any matter or energy, there was just information, a process that was observing and learning about itself, and in doing so, it essentially brought reality into existence.
And the origin point for all of this is pretty fascinating. According to the theory, everything we see, everything we know, emerges from this one single self-referential unit of information called psi1. You can think of it like the very first bit of code, the one informational seed from which the entire cosmos grew.
And from that simple little start, a really powerful rule emerges, which the paper calls Relativision 18. Now here's the crucial part. This isn't just some cool philosophical idea. It's a mathematical framework that actually claims to unify gravity and electromagnetism. That's kind of the holy grail of physics that scientists have been chasing for more than 100 years.
Okay, hold that cosmic thought for a second, because now we're going to zoom all the way in, from the scale of galaxies right down to the scale of our own cells. And you're about to see how this all connects.
Sound familiar? This is phi1, but with a lowercase pi. It's the biological version of the cosmic theory. It's proposed as a real measurable number that shows the informational order of our bodies. Think of it like the resolution on a photo. High order is a sharp, healthy system. But as we age, as things decay, that informational picture gets blurry and corrupted.
And hey, this isn't just theory. The research gets into some very practical uses, like coming up with new ways to preserve donor organs. If you start thinking of liver not just as biological tissue, but as an informational system, you can find much better ways to keep its order and function intact outside the body.
And that leads us to this proposed ESDC platform for regeneration. It's basically a four-step process. First, it acquires data by reading your body's epigenetic maps. That's the software that tells your DNA what to do, to find any bugs in the code. Second, it sends a command with molecular instructions to fix that code. Third, it eliminates the bad, damaged tissue. And finally, it creates the perfect environment to regenerate brand new, healthy tissue right where it's needed.
So let's take a breath. We've got a theory of the universe based on information and a theory of medicine based on information. Is the connection starting to click into place for you?
I mean, just look at this. The parallel is just striking. It's almost a perfect mirror. On the cosmic scale, you have the big phi1 leading to rules like relativity 18 that govern gravity. On the biological scale, you have the little phi1 measuring the order that's governed by epigenetics, which in turn influences aging. It's the exact same pattern, just playing out on two completely different scales.
So there it is, the unifying thread. The bridge connecting physics and biology in all of Lenci's work is information. It reframes everything, from the universe to our own bodies, not as just a collection of stuff, but as these dynamic, informational systems that we can understand and maybe even rewrite.
And that finally brings us back to that strange third paper about motivation. So why is it here? Well, maybe it's because in this model of the universe, information isn't just passive. The Novus theory describes a universe that's always observing and learning. And on a human scale, what is that fundamental drive to learn, to grow, to process information? We call it ambition. To even come up with a theory this huge required an unbelievable amount of that drive, a deep motivation to find one single elegant answer for everything.
So if we run with this idea, if this informational framework is for real, what does it actually mean for the future of our health?
Honestly, the potential applications are staggering. We could measure our biological age with incredible accuracy. We could design and track anti-aging therapies, monitor how someone is recovering from heart failure, and build entirely new ways to regenerate our bodies. At the end of the day, this whole approach treats our biology like a programmable system, like an operating system that we can finally learn to debug and upgrade.
And all of this leads to one last, really deep question. For centuries, we've been reading the book of life. Now, it seems like we're finally learning how to write in it. So if our very existence, from our cells all the way out to the stars, is just a story written in the language of information, what new chapters will we choose to write?